Next up, TCP Sequencing and Reliability. Now we've already talked about TCP sequencing and reliability, but this time we're going to go take it a step further and look at those mechanisms that actually do this. So we're going to take a look at the TCP header. This is not intended to be a deep look into it. It's just going to be a real brief look into it since we've already taken a more extensive look into it. We'll talk about sequencing numbers and what those look like. We'll talk about acknowledgements and what happens to trigger data retransmission. So we'll talk about all of those components. Now here again is that TCP header that we have. We have 32 bits across here. We have a source port where it's coming from and a destination port where it's going to. We know the destination port flags some sort of service that is going to be connecting to. The source port establishes that connection, or that whatever tab is open, or that whatever that connection, it helps track that connection. And then we have this sequence and acknowledgement numbers. So we're going to get deep into this sequence and acknowledgement numbers and take a deep look at what those actually look like. So the data that we're sending across could really vary widely. It could be just a little bit of data, or maybe perhaps there's no data at all that we need to send over. Or perhaps it's a very large amount of data and it needs to be broken down into lots of different segments. So we could have anywhere from just one segment that we're sending to one side to lots of different segments that we're sending to the other side. So this is just representative. We're going to take this data and we're actually going to break it down into 3 components here. So layer 4 will break it down into 3 components here. And then that data needs to have some additional information, so that way when it gets to the other side, it can address what service it belongs to, and has a sequence number, so that way it establishes that connection with the other side, and it knows how to get reassembled on the other side. So all that information is found within the header. And so we're going to take a look at what specific information is going into that header for sequencing and for acknowledgement, and take a look at how that looks, what that looks like, and how it gets information over there. Okay, let's talk about sequencing numbers, how things are sequenced. This device right here is asking for a web page from this device right here. So even though initially the data flow is from this device, which is establishing a connection with this device, the flow of most of the data for a web page is actually going to go in reverse. The flow of data is going to go from the server to the client. The client is requesting a web page, and then it is downloading the web page from the server to the client. And so this information is going from the server to the client. So let's say that this is the first segment, this is the second segment, this is the third segment. And before I labeled these as 1, 2, and 3, but I did specify it's not quite the way the numbers actually look. So let's take a look at what the numbers actually look like. So what it does is it labels the first byte in here, the first byte that's coming across in that data. It's just the data part of this, and it gives it a number. So we're going to say it's going to label it as 53,000. Maybe for interest of simplicity, I'm going to actually label this 53,001. All right, 53,001 is the first byte. All right, let's say the data that's in here is 1,000 bytes, and I'm going to use this so that way it's a little simpler with the math with this. But we could actually see a lot of different variety with how big these segments are. So we're going to say that this data within here is 1,000 bytes. And so the last byte in here is going to be 54,000. So we labeled each one of the bytes in here. So we got 50,001, 53,001, 53,002, 53,003, 53,004. Each one of those bytes has a number that's assigned to it. And the last byte of this is 54,000. So the sequence number is actually going to be the first byte of data, whatever that is. So in this example right here, it's 53,001. That is the sequence number. So I'm asking you a question right now. I want you to tell me what the sequence number of this next segment is. It's the next byte of information. What is the next sequence number? If you answered 54,001, you would be correct, because that is the next byte within this data. 54,002, 54,003, 54,004, 5, 6, continues to count up, and to the last one of this segment, the last one is 55,000. If we're saying that the data payload of this segment is 1,000 bytes. All right, so we've got 1,000 bytes. That means the last byte on here is 55,000. Question again, similar answer to what it was before, is what is the next sequence number? It would be the next data. And so we would call this byte is 55,001. So if you answered 55,001, you would be correct. And then each subsequent byte, 55,002, 55,003, 55,004, all the way to the end here would be 56,000. All right, if we had another segment after this, where would it begin? The next byte in this transfer would be 56,001. So that would be the next one as it's sent over. And it continues to do that. And now what happens is this, as this information gets over to the other side, now it knows that, well, this is the first 1,000 bytes right here. This is the next 1,000 bytes right here. This is the next 1,000 bytes right here. It knows how to reassemble that based off of that sequence number. If for some reason, if this packet doesn't get there, then it would recognize, because it would see that, well, I've got 1,000 bytes of 53,001 to 54,000, and I got 55,001 to 56,000, but I seem to be missing something. So that is how the sequencing happens within there. And the sequencing can be quite large. Like I say, this number is randomly chosen there at the beginning as it sets that communication. But if you're doing something like Wireshark, it will actually change that number to 0 so you can better understand it and see what bytes are traveling back and forth. So if you're using some sort of packet sniffer or some sort of way of taking that packet and actually looking at it, your numbers actually might look a little different than what they actually are. And that's just because that program is adjusting that so that way you can more easily identify the segments. But what's truly happening on the backside is that this first number is randomly chosen, and then it just sequentially counts up from there. And we know the range is pretty large because we got 32 bits to deal with this sequence number. So we got more than 4 billion combinations or 4 million bytes that we have before we run out of chances to label these bytes. So that is sequencing. So now this machine has requested a web page from this machine right here, and it is now sending the data over. We've got this labeling that's happened. So this first one was 53,001. This first byte in this segment is 54,001. And then we've got 55,001. We said that each one of these are 1,000 bytes, mainly for the interest of making this all simple calculations. And so now what's happening is we need to acknowledge what was sent over. So this machine gets all of these segments right here. These segments, 53,001, 54,001, 55,001. And now it's sending an acknowledgement back to the server saying, I received this data. And it has its own sequence number, which is a little different. We'll get into that in a second. But it also has an acknowledgement number. And so that acknowledgement number is the next byte it's expecting. The next byte it's expecting. So if it's gotten 53,001, 54,001, 55,001, the question is what is the next byte that it's expecting? So this last segment right here ends with 56,000. So the next byte that it's going to be expecting is 56,001. And then it's going to send that acknowledgement over saying, I'm expecting as a next byte 56,001. This server gets that and realizes that all three of these segments got to the computer on the other side successfully. It has sent this 3,000 bytes of data over to the other side successfully, and now is ready to form the fourth segment in here. So it starts forming the fourth segment that's going to be sent over there. And within the TCP header, the next sequence number that it's going to submit over there is 56,001. That's the next sequence in this. And so it's going to send that over to the other side with the sequence number of 56,001. All right, let's take this the next step further. Let's say we're sending lots of data here. Each of our segments is 1,000 bytes long. For the interest of simplicity, we see once again in our example 53,001, 54,001, 55,001 is the sequence numbers that are being sent from the server to the client machine. The client machine sends an acknowledgement back and says, what I'm expecting next is, if this is byte 55,001, there's 1,000 bytes here. So that it'd be the next byte it's expecting is 56,001. I'm expecting byte 56,001 next. And then that's when it sends next. So this is the next segment that it sends with the sequence number of 56,001, the next one 57,001, the next 58,001. This computer then sends an acknowledgement and says, all right, I've received up to 59,000. So the next byte that I'm expecting is 59,001. So then we see the next sequence number is 59,001, then 60,001, then 61,001. And then the next acknowledgement is, okay, the next byte I'm expecting is 62,001. And so the process continues until all the information gets over for this website onto this computer, and that computer acknowledges, and then at some point in time probably tears down that connection and says, okay, I've got everything I need, thank you very much. Okay, so what happens if there is packets that are missing and something doesn't get transmitted? What happens and how does this get retransmitted? So this server is sending, it just got through finishing sending these three segments. And to use the same example that we've been using, the sequence number on these is 53,001, 54,001, and 55,001. This then PC is expecting more, but doesn't hear anything. And so it starts wondering what's happening. How come I'm not receiving more information? So now it sends an acknowledgement over. And this acknowledgement says is that I'm expecting now 54,001 because perhaps these two didn't get to that end of the machine. So it's expecting the next data set that it needs is 54,001, and it's sent across that in its acknowledgement. This then web server right here realizes, oh, I sent this data, but this device over here apparently didn't receive that data. So I'm going to then resend. So it resends 54,001 and 55,001, resends those two segments, so that way that PC that's asking for that information, that desktop that's asking for that information, gets that information, can assemble the web page, and then present it to its user. Okay, there's a lot of information here. Let's summarize this, and I want to go over one other concept of here because we've got data that flows back and forth. So we actually have two sets of sequences / acknowledgement numbers. And so there's something interesting that happens in here. So I'm going to demonstrate that with these two devices right here. And so we've got a PC here that's requesting web services from this web server right here. So the first thing that we see that's sent over is the request. There's a little more to it than this, but for now we're just going to send a simple packet over there. Let's say this packet is 100 bytes big. First of all, when it gets sent over, it's going to have a TCP segment header. And so that TCP segment header has a sequence number in it. It's going to be randomly generated. So let's just choose 20,001 as an example for this. It sends that over. It actually doesn't have acknowledgement at this point in time. We're not going to use the acknowledgement field. And it sends it over to the other side. So next step is that there is going to be a segment that's going to be a response. And let's say we're going to send a few pieces of data here. So the first one, let's say it sends 1,000 bytes over from this PC to, from this web server to this PC. And it's going to have its own sequence number. So it's randomly going to generate this to make it much different than the other side. Let's just say this is 2001. Okay, so that's what it's sending over from this side to the other side. It also has an acknowledgement number, so it's going to acknowledge the next byte it's expecting from the PC. So in this case right here, if 100 bytes was sent over, if the sequence number was 20,001 and 100 bytes was sent over, then the acknowledgement number here is going to be the next byte, or it's going to be 20,101. It's going to expect 20,101. All right, so then that gets sent over to this PC. This PC, let's say it doesn't acknowledge it quite yet. Maybe there's some more data that's flowing here. So it's going to send a few segments before it gets an acknowledgement back. So it's going to send the next sequence number. It's already sent 1,000 bytes. So this next sequence number is 3001. The acknowledgement number has not received anything new from the PC, so it's still 20,101. And then it's going to send some more data, and let's say it's also 1,000 bytes. And so now we've got 4,001. And the acknowledgement number, it hasn't received anything more, so it's still expecting the next byte to receive from the PC is 20,001. This PC is going to need to acknowledge it, and so where it acknowledges it is going to kind of depend on what is negotiated between these two machines. But we'll just say after 3 segments, now this PC needs to send an acknowledgement. And within that acknowledgement, it sends what is the next byte it's expecting. And in this case right here, it's going to be 5,001. So that's the next byte that it's expecting from this web server. The sequence number is, it's not going to, in this example, it's just acknowledging what data is already being sent. So it's actually not going to have any more payload to this. So we're going to say that the data it's sending is just going to be 20,101, since it's not sending any data. So then it gets over to this other side, and this PC decides to send 3 more packets. They're all 1,000 bytes. And then we've got sequencing up. So we've got 5,001, 6,001, and 7,001. The acknowledged number has not changed during this whole process. So that's all going to be the same. Now this PC is going to send something back. Let's say in this case it does have a little bit of data attached to it because it's happy now, and maybe it's closing the connection or something to that effect. And so the next acknowledgement number that it would send over is, it's expecting next 8,001. And the sequence number of this would be still 20,101. And it sends it over to the other side, and so on and so forth. So this communication happens and continues to happen until all of the information is received from one side to the next. So that is how communication happens between these two devices, and how it gets reassembled, and how it recognizes if there's any data that's lost. All right, a lot to it. Once again, TCP, there's a lot of information in here. So we talked about that TCP header, did a brief overview of that. We talked about sequence numbers and how those sequence numbers work. We got into acknowledgement and also how data is transmitted. And we finished it up with a summary of how that data flows back and forth and an example of that. Thanks for watching my video. If you liked it, could you hit that like button?